Hi, my name is Julia Silge, and I'm a data scientist and software engineer at our studio. And today in this screencast, we are going to learn about R packages. No, not how to use R packages, hopefully that too, but actually data about R packages. This week's Tidy Tuesday is about counts of vignettes at different release dates for everything on CRAN. There's also got everything on Bioconductor too, which is amazing. In tidymodels, we recently, just very recently, did new releases ourselves of a parsnip, the package for creating model specifications, as well as the parsnip extension packages. There are core tidymodels packages that you attach when you type library tidymodels, but there are also extension packages, which are they're non-core packages, which are often for like more specialized data analysis or modeling tasks. And we did releases of those as well to kind of revamp our documentation system, which it looks great now. I'm super excited about it. And today we're going to walk through how to use one of those, how it works, how you get started, and how you deal with some of the quirks of some of these different kinds of models.
All right, let's learn something about R packages. So let's start by reading in this data here. So I think the data had both CRAN and Bioconductor packages. I'm just going to look at the CRAN here. And we've got packages, the version at which they, when they were released, some dates. Looks like the dates are, some of the dates are encoded differently. This is a character column right here, and then two ways of making vignettes. So just to kind of like see what this is like, let's I'm gonna look. Whoops, what am I doing? I'm gonna look at a few packages that I maintain. So here are packages for tidy text back to this point at which there were versions before that, but this is kind of an unusual situation for tidy text. The versions previously to that had to be removed from CRAN because of a licensing issue with the data set. But we've got like the date when it was released and then the number of vignettes. And, we had 4 for a long time and then we dropped down to 3. So that actually went down. Some of those, in that particular case, I know that the reason we brought them down is that we moved some of the content to the package down site and not to an official CRAN vignette because of the extra packages it took to run the vignette. So let's look at our sample. So this is our sample back to 2017. Here are the versions. And again, it was like, it went up, way up, and then kind of went back down again because some of these got moved actually to tidymodels.org. We decided that it was better not to have them in the package as a vignette itself. So that just gives you a little bit of an idea of what this is like. So let's... I want to build a model, like I talked about in the intro, that is basically per vignette. So let's take, per package, I'm sorry. So let's take this, let's group by package like this. And then let's summarize. So let's summarize, let's say this is going to be the first release date. So these are all, fortunately, in order. So if we say the first date, like that, we'll get the first time that each of these was released. Then let's say how many releases there were, like that, number of releases. And then let's say the number of vignettes as of today. So let's say, we'll add those two numbers together. Last of that RNW field or variable plus last of the RMD, like this. So what we have here is for every package that's on CRAN, when release date. When was it first released? How many releases has it had, and how many vignettes are there as of today, as of the last release? Great. Okay, so let's see how many. Let's change that release date so it is actually a date. Maybe I can use this in some modeling. Maybe. So let's say lubridate YMDHMS of release date, like that. So it's not. Let's see how many this throws away. That's like a tenth. You know what? Let's not do that. Let's keep this, and let's not use the release date in modeling. Let's just use releases and vignettes. All right, so let's call this vignette counts. All right. So we've got our new data set, vignette counts, which is ready to go. And then so I'll, I see a lot of zeros there, even at the beginning. So what if we take mean vignette counts, vignettes, and let's say how many are less than 1. Okay, so this is, that's a lot, right? Like, so most packages on CRAN don't have a vignette. Like, 2/3 or so don't have a vignette. We can look at this in a different way, maybe by like a histogram. So let's say vignette counts, and let's that's right. Put the number of vignettes, and let's make a histogram like that. And wow. So many zeros, right? So this distribution has a ton of zeros. We could do something like scale x log 10, but all those zeros, right? Like it's going to just take away the zeros, and that's really not what we want to do. You could add 1 to it, but 1 is kind of an important number. So one thing I like to do when I'm in this situation is to use something from the scales package. It's called pseudo log transform, and let's do base 10. I think that's a little bit easier to understand, like that. And then let's not have so many bins. Let's say bins like 12 instead of 30. Okay, so here's like a pretty good histogram. Keep in mind, this is on a log scale right here on the x-axis, but it helps us kind of see it a little bit. But this is like, this is a distribution with just tons and tons of zeros, so many zeros. I'm just curious, let's say vignette counts, like what are these packages that have this, have 20 vignettes? I don't know. Let's see here. Okay, so here are the 4 packages that have more than 20 vignettes. That's a lot of vignettes to write. I'll have to take a look and see what's going on with those, because that's quite something. All right, let's just make like one more exploratory plot here, and let's look at what I think we're interested in when it comes to the modeling, the relationship between the number of releases and let's say in vignettes. Let's say if there is a vignette or not at all. So let's make a new column, has vignette, and is equal to whether vignettes is greater than 0, like that. So I made a new logical column here, and let's put vignette on the x-axis, releases on the y-axis. We can maybe distinguish these with some color like that. And let's make a box plot. Let us make it a bit transparent like this. And there we go. Okay, so let's make a few more changes to make this better. Let's flip it like this. Let's scale that y-axis. Here we should be able to use log, just regular old log, because everything has at least one release, or it wouldn't be on CRAN. And we don't need the legend. And what else? let's make color equals has vignette as well. Okay. All right, that looks pretty good to me. Okay, so this I think is pretty clear. So we've got on the x-axis, we've got the number of releases, and then does it have a vignette or not? And we do see this shift. The things that have a vignette have on, like, I think that's probably real, but we'll do some modeling and we'll see how real is it. How real do we think it is? Okay, so let's talk about modeling this. So boy, those zeros, right? And well, so the zeros, and then also this is count data. So tidymodels, has a set of core packages. Let me do this here. So if we load tidymodels has a set of core packages. Here they are. So these are what are attached when you load tidymodels. And these, each of these packages has like a different purpose. Tune is for hyperparameter tuning. RSample is for resampling. Parsnip is for models. But in the tidymodels universe, I guess you can say, there are also what we call extension packages or non-core packages. One of them is called Poisson reg. So there's ones for bagged models. There's discrim, like there's all these like different kinds of extension packages for Parsnip. So if I load this one didn't get loaded before, but I'm going to use it. And what Poisson reg has is Parsnip functions for Poisson regression models. So they, I'm sure a lot of you know this, but like Poisson regression models are good for count data. And that's what we have, counts of vignettes. And we can use a Poisson distribution to model that count data. So there's different engines here for the Poisson regression model. And so let's start just with the basic one, the default engine. So let's build a model here. Actually, I'm just going to put it in a I'm going to put it just in a workflow. So let's call it Poisson workflow. So I'm gonna define a workflow here. First, I'm gonna put a formula. So vignettes is the outcome, and releases is a predictor, just one of each. And then I'm gonna say a model specification. So I'm gonna say Poisson reg like this. So this is just default Poisson regression. Here. So it tells us, what's going on. It's for regression. It's going to use GLM to fit this. And then if I want to fit it, what I do is I just say I fit the workflow on the data. So let's just fit it to all of the data like this. And we can get out. Whoops, I should define all of them. There we go. Okay. So what we have here is the result. It's now a trained workflow. It's telling me what the, what the coefficients are, and now I could do anything that I want with this model, like, I could fit it to resamples. I could, there's tons of things that I could do here. I could see how well it performs, how well it, what a good job it does at predicting, all that type of thing. But this data, wow, it's counts, right? Counts of vignettes, but also it has so many zeros. And so we can build something that's called a zero inflated model. So what a zero inflated model here, so it's a different engine. And so this fits a model that's like a mix. It has a couple of terms. So zero inflated Poisson is good when you're in a situation where you have a ton of zeros. And so I like, people call it a zip model, which is very fun. And so a zip model mixes two models. One of them generates the zeros. So there's a piece of the model that generates the zeros, and then there's a piece of the model that models the counts. So you have these two sets of these two models that are mixed together to make a zip model. So how do we do this? So let's make a separate zip spec, and so we'll say Poisson reg like this, and then I'm going to set the engine to this this engine here, like that. So now I'm, oops, not N, the whole thing. There we go. So if I look at this model specification, it works just like any other parsnip model specification. It just comes from like a different package, and it's made for this more specialized task. And so it's got this engine, which is ready to fit a zero inflated, a zip model for me. So let's put, first, let's just look at this here, how this works a little bit. It requires a special formula for these zero inflated Poisson models. So if I were to fit it, I would need to put in a model formula that looks like this. Notice this bar in the middle. So what this is, this pipe, Unix pipe or whatever we want to call it, what this does is it says, okay, here's my outcome. And then here is some predictors that are for the count data. And then here is some predictors that are for the probability of zeros. So we have we have a special formula that's here that's used to specify which columns affect the counts and which affect the model for the probability of zero counts. So it looks like this. So this is a special formula, right? Like this is kind of a little weird. And actually a lot of the extension packages like Poisson Reg, multi-level mod, a bunch of them use these special formula type situations. And so let's walk through how to add that to a workflow specifically. Like that example shows how to fit it. But if what you're like, oh no, I need a workflow because I have a special pre-processing, or I want to, use that sort of workflow infrastructure with the benefits that come with it. So, we can add the model here, zip spec, the parsnip model specification, but then we also need to add this special formula. So for us, we're going to say vignettes explained by releases, and then we need that bar. We only have one predictor here, so this is also going to be the predictor that is used for the zeros to model the probability of a zero, like the zero generating and then the count data, these two pieces of the model. So we pass that in, but we also have to tell the workflow a little bit more. So we have to tell it, we could do add formula. Oftentimes I think it's clearer when you're working with a special formula to use add variables here. And then you need to put in two things. You need to say the outcomes, which here is vignettes, and you need to say the predictors, which for us is only a single predictor, but you can have more here. So let's call this zip workflow, like this. So if I look at this workflow, it's got outcomes and predictors, it's got the model, and then it also has in it this special model formula which says how the two bits work together. And so now I can do anything, just like I did before. I can fit this workflow to the data here. So notice what it looks like here. So it's got the count model and the probability of getting zero. So the zero inflation model, the zero generating model, whatever you want to call this. So these are now, we see them both. And notice that it is lower. Let's remind ourselves here. So here we see here that the more releases you have, let's see, did I do this right? Yeah, the vignettes releases. Yes. So the more releases you have, the more vignettes you have. This is just from modeling as count data. But when I do it with a zero inflated model, this goes down, right? And that's because we're accounting for all the zeros. We still see the more releases you have, the more vignettes you have. But now we see this, which is that the more releases you have, the less likely you are to have zero vignettes. Another way to say that is the fewer releases you have, the more likely you are to have a zero vignette. So we have these two pieces that we fit together, and then if we were to predict, it would predict with them together this model that is a mix of the combination. So that is how to use, a parsnip extension package model, how to use a special formula, which often comes up in these kinds of models. And then, but now we have this, we can use all of the tidymodels infrastructure. These models are often used for inference, not so much for just to make really accurate predictions, but to understand, the relationships more, to understand what's going on and why. So let's look at the model coefficient. Specifically, let's find Bootstrap intervals for them so that we understand. We got like these numbers fitted to all of the data one time, but like can we use the Bootstrap to understand what the distribution of those model coefficients are? So let's do that. Let's make some bootstrap resamples. Let's bootstrap our whole data. Let's do 1,000, and yeah, that should work, I think. That's all we need. Like this. So we have, this is actually a pretty big data set, but let's show how to do bootstrap resamples anyway. This is going to take a little while to fit 1,000 models to all of that data. It's actually pretty big. So we can fit the models, right? Like let me walk through down here how I would do that, right? So I'm definitely going to try to use the parallel, my cores, to get this to go faster, and like set a seed. And so I can say, let's call it zip result. I can fit to the resamples here. I'll say the workflow is what I want to fit. What I want to fit to is the folds, right? So I could do this. Really, although that would get me out is the metrics. So if instead what I really want to know is about the model coefficients, I am going to need to pass in a little function to do that. So let's make a little function like that. Let's call it get coefficients, and we're going to pass in like a fitted workflow. Let's call that X here. And then let's say we're going to extract the engine fit like this from the model. Extract. So this will get out the underlying like PSCL model from it, and then let's tidy it. There's two ways you can tidy these zero inflated models. If you just do this, I don't know if you get all of them or whatever, but let's just get the zero part. So this is just going to get us the model coefficients for the zero generating model, the probability of having a zero. So if I can so let's say I'm going to do this again, and then I'm just going to take that output, and I am going to get coefficients like this. So I guess that means I don't. Oh, no, I extracted the fit. Okay, perfect. Okay, so this is a tidied version where we have the intercept, we have the releases, how are they related here? So this is that same thing I got up further there, and now what I want to do is I want to do that 1,000 times. I want to get like 1,000 of these values. So what I am going to do is I am going to create a control object like this, and I'm going to use control resamples. Let me remind myself how this works. So in control resamples, you can say, is it verbose? Do you want to save the predictions? What we're going to do is we're going to extract something. So the extract takes a function. Extract, where is it? It takes a function that will be used to like pull out pieces from the model. So I'm not going to keep all 1,000 fit models. Instead, I'm going to get out these coefficients from all the model. So let me put that in here, my control objects like so. And do I have everything right? Okay, I think so. Let's start. Nope. X. Right. It needs to be like this. Okay, so it has started. So what is it doing? For all 1,000 resamples, it is going to fit the data to these Bootstrap resamples, which are, remember, these are all different Bootstrap resamples of the original data. So I'm going to fit that zero inflated model to this data, get out the coefficients, fit the zero inflated model to this data, which remember is different, get out the coefficients and so forth. So it is doing that with the backends I have available. This is not a very slow model. Like, this is a pretty fast, quick model, but I'm doing it 1,000 times on fairly big data sets. So I am going to pause the video right here and then come back when it is done. All right, it's done. It did it. So notice that for each of the 1,000 Bootstrap resamples we have, it computed metrics, which, we could use if we were interested in this model for its predictive capacity. It's got notes, which are empty, and that has this extracts column. So what is that? That's where our coefficients went. So let's look at it. So let's look at that'll print out all 1,000. I'm not going to do that. Let's look at, some random one. Whoops. Some random one that's in there. So what's in here in each of these is a little tibble that tells us which config here, which we only have one. We could have done different models if we were tuning something different, preprocessors and all that. We only have one. So for us, this is not so relevant. And then here is where the tidying results, the coefficients are that look like this. So let us walk through how to get that out. So zip result, let's just take the ID and the extracts like that. There we go. Let us unnest it. Okay, so now we know for the config, where it is. We already knew that. So we have to do it again. Let's do it again. Okay, there we go. So we just keep on nesting till we get to the thing we want. And now we have, these are the coefficients for the zero inflated part of the model, what is generating the zeros. And we've got for all of these bootstraps, what is the estimate of the model coefficient for that term, for like how many releases there have been in our packages and how many vignettes we'll end up getting for that, like whether it will be a zero or not. That's what those are. So we can now plot these. So let's put estimate on the x-axis. Actually, let's just make a histogram again. I think it'll be nice if they're different colors. And let's make a histogram. I don't think we won't need that legend again because I'm kind of doing it twice like this. Okay, here they are on one plot. We definitely don't want them on one plot. So let's say facet wrap vars term like that. Great. Let's say scales equals free X, right? Perfect. I love it. And what else do we want to do here? Maybe it will look kind of nice if we make little kind of outlines like that. And maybe also I'll show where the zero is, because that can be helpful for understanding what this is doing. So let's say the zero, a vertical line at 0, and let's say line type equals 2, size equals 1.2, color equals, color gray 50, like that. Like so. Okay, I like this. Okay, so what we're seeing now here is for the part of the zero inflated model that predicts whether something has a 0 or not. We've got the intercept over here, right, which tells us overall how many are 0 in the sample. And then what the releases, what this set tells us is for any given increase in let's do it like this. So for like, say for an increase in releases, what happens to vignettes? The probability of the vignette. So this is a negative number. So what we have here is that more releases means a lower probability of A lower probability of having a 0. So that's true, and also more releases means more vignettes. So that's what the zero inflated model tells us all together.
All right, we did it. We trained a zero inflated Poisson model for these counts of our package releases and vignettes. So if you're ever in a situation where you got so many zeros, remember, you can use a zero inflated model, and we can create these models with the tidymodels framework, so that then you can do any of these things that we've talked about or that you find in any documentation, for tidymodels. You can, evaluate predictive power. We can look at model coefficients, and that's what we did today using Bootstrap resampling. So I hope this was helpful, and I will see you next time.